Welcome to Wastewater 101, a series of videos designed for health department professionals engaged in wastewater surveillance work and interested in learning more about wastewater and what their utility partners do. This is part 2, How is wastewater collected? I'm Anna Marotra, Director of the Wastewater Surveillance Program at the Water Environment Federation, or WEF. And I should note that development and production of this material was made possible through funding from the US CDC to WEF under Cooperative Agreement CK20-2003. And this material is solely the responsibility of WEF and does not necessarily represent the official position of CDC. So in the US, wastewater is primarily collected one of two ways, either through sewers or through septic or what are called on-site systems. Sewers are by far more commonly used, but it turns out that it's tricky to nail down exactly how many people are connected to a sewer. According to 1990 census data, which was incidentally the last time the census included a question about where household sewage goes, just about 75% of people were connected to a sewer. In 2017, according to the American Household Survey, nearly 82% of households were connected to a sewer. So it's probably safe to say that more than 75% of US residents and probably more than 80% use sewers. By the way, many new homes are built with septic systems, so it's unlikely we'll ever get to 100% sewer connectivity. And I just wanted to share an alarming statistic I found that was in those 2017 American Household Survey data, namely that 1 in 3,500 households participating in the survey reported that they had no wastewater treatment, no septic system, no composting toilet, no sewer, nothing, which I found that really hard to believe. So sewer connectivity does vary across states and territories, as shown in this map, from a minimum of 43% in Vermont, 45% in Maine, up to 88% in Nevada, New Jersey, and Utah, and 90% in California. Keep in mind, these data are from the 1990 census, and so are more than 30 years old, but I would guess that the general pattern still holds. On the right-hand side, by the way, that's a precast concrete manhole, which is the most common way manholes are made these days. So you can see it being installed in the street. Sewer connectivity doesn't vary quite as much across income levels as it does across states. These data are from the 2017 American Household Survey, and on the x-axis are different household income categories, with the one all the way on the right-hand side being $120,000 per year or more. And then on the y-axis is the percent of households using septic systems. Most of them do use septic systems, although I guess some households still use cesspools. And you can see at the highest income bracket, it's about 13% of households are using on-site systems. And then for the income brackets below 120,000, it varies in a pretty small band from 15 to about 19%. So we've been talking about sewers and sewer connectivity, but what we really mean when we talk about the infrastructure that collects wastewater from homes, businesses, institutions, and industries is collection systems. And collection systems are just that, the systems that convey wastewater from its point of use to a treatment facility. Sometimes you might hear wastewater professionals using the term service area, and this is just the boundary of the collection system that's owned and or operated and or maintained by a utility. And a term that's gained popularity in the past few years is sewer shed. And it's analogous to a watershed in that it is a boundary within which all wastewater flows to the same point, same outlet. But collection system describes what's inside that sewer shed or inside that service area boundary. And it is still the term that's most commonly used in the wastewater sector. So a collection system is comprised mainly of 4 components: piping, that's the actual sewers; storage, this can be retention basins or deep tunnels; pumps, and outfalls, and those can be either overflow structures or simply discharge into a treatment facility. Not all collection systems have storage, but many do, especially large combined systems. And there are other collection system elements not shown here, such as siphons, which are static structures that essentially pump the wastewater without any mechanical power input. But these are really the main ones. And there can be many, many different diameters, types of pipes, and many, many different sizes and types of pumps in a single collection system. So it's helpful to remember that in most urban and suburban communities, the wastewater collection system is one of the largest, most valuable infrastructure assets. It's just one that's particularly hard to see. And I know I just mentioned combined systems or combined sewers, and the distinction between combined and separate sewers was covered in part 1 of this series. But briefly, a combined system, which is what is shown in this diagram here, which comes from the EPA via Wikipedia, is a collection system in which the stormwater that enters storm drains is conveyed in the same sewer network as the rest of the wastewater, the domestic sewage, the industrial flows, and the infiltration and inflow. So what this means is that during a storm event or wet weather, you can get much higher flows in your sewer system. Now, many sewer systems are a mix of combined and separate sewers. Some are completely separate. But again, you can learn more about combined and separate sewers in part 1 of this series. Another helpful distinction to make for sewers is gravity versus pressure sewers. So this is a very simple schematic of a gravity sewer. And a gravity sewer is one that flows, well, by gravity from one manhole to the next. And these don't necessarily run full. The alternative to a gravity sewer is a pressure sewer. And a pressure sewer line is what's shown in this diagram coming out of that blue box, which is meant to designate a lift station. And in this lift station, we have a wet well, and we have a type of a pump that's called a submersible pump. And so those pumps are pushing the wastewater through the pipe called a force main. And so that pipe is necessarily running full, and it's under pressure. And technically what I'm showing is a positive pressure sewer line because those pumps are pushing the wastewater towards the treatment plant. There are also negative pressure sewer lines called vacuum sewers where the pumps pull the wastewater towards the treatment plant, but those are not very common. So when we talk about pressure sewers, most of the time we're talking about positive pressure sewers. And just a note that really only gravity sewers or negative pressure systems, vacuum systems, can technically have infiltration and inflow. But because most collection systems have at least some gravity sewer in them, that's why I&I is somewhat universal. And again, please watch part 1 for more information on I&I. So in reality, most collection systems are a combination of gravity and pressure sewer. And again, the gravity sewer is simply called a gravity sewer. The structure that houses the pumps is called a lift station. It can also be called a pump station or a pumping station. And the sewer that comes out of the lift station is known as a force main. The only reason all of this matters for wastewater surveillance is that the type of sewer in your utility partner's collection system will dictate the types of sampling locations that can be used, but more on that later. So here are 2 collection system examples. The one on the left is from Great Lakes Water Authority, or GLWA, in Southeast Michigan. They discharge most of the time to the Detroit River and sometimes to the Rouge River. There are nearly 3 million people in the GLWA service area, and their collection system is actually an agglomeration of individual sewer districts outside of GLWA. The total collection system across their 19-member sewer districts is 946 square miles, and each of those sewer districts has hundreds of miles of sewers and dozens of lift stations. They have a mix of combined and separate sewers, with sewer districts in and close to Detroit tending to have more combined systems. The example on the right comes from Clark Regional Wastewater District in southern Washington State. Their treatment plant discharges into the Columbia River. They are the one and only sewer district in town. They own and maintain 750 miles of sewer and 85 lift stations in their 47 square mile collection system. And they're providing wastewater collection and treatment for 100,000 people living in their service area. And their collection system is separate. So a little bit more about the sewers themselves in a collection system. The pipes can be made out of a wide range of materials such as ductile iron or PVC. Older sewers can be made out of clay. And sewers can range in size from 6 to 8 inches in diameter, all the way up to 8 feet or more in diameter. We typically think of sewers as being organized in hierarchy from laterals. So those are pipes that convey wastewater from a residence or other building to local sewer mains, to regional trunk lines, and to interceptors. And this is in increasing diameter size from left to right in this hierarchy. Some collection systems might really just have the first three, with the trunk lines conveying the wastewater to the treatment facility. And some collection systems have multiple interceptors that convey the flow to the treatment plant. And so it's possible at some facilities to sample only at the treatment plant influent, but still capture flows from distinct regions by sampling from the different interceptors. Just a note on manholes. Manholes provide access to gravity sewers and allow change in direction, pipe diameter, and slope. Manholes are usually at least 4 feet in diameter. They are usually spaced about 400 to 500 feet apart, but this spacing really depends on local regulations. And the manhole covers can be mini works of art. Here are just 5 manhole covers that I came across in the past couple of months from San Juan, Puerto Rico, Reno, Nevada, Montreal, Canada, Denver, Colorado, and San Diego, California. So then when it comes to sampling in the collection system, you really have 2 options, manholes or lift stations. Technically, you can also sample from building cleanouts, but that's really upstream of the collection system altogether. So I'm not going to talk about building cleanout sampling here. So the nice thing about manhole sampling is that it can capture flows from specific neighborhoods, institutions, or buildings of interest, but they have some potential challenges. It can be challenging to access manholes safely. They can be in the middle of the road. They can even be paved over. Manholes do not have power outlets, so you'll need to use a portable auto sampler that uses battery power, or a method such as a grab or passive sample that doesn't rely on a piece of powered equipment. And we'll talk a bit more about sampling in part 5 of this series. Some manholes can be very deep, and when the depth to sewer is more than about 20 to 25 feet, that is deeper than the capabilities of the peristaltic pump in the auto sampler can handle, or the capabilities of a pump you might use to collect a grab sample. And for some manholes, especially for those that have variable flows, it can be challenging to keep that intake tubing seated in the flow. And most manholes do not have permanent flow metering installed. So you're going to have to do your best to estimate or temporarily measure or somehow otherwise get the flow information. Your other primary option for sampling in the collection system is at lift stations. So like manholes, these lift station samples will capture flows from neighborhoods or larger regions. The nice thing about a lift station is that they will usually have power, so it'll be easier to set up a refrigerated auto sampler, and you don't have to deal with babysitting a portable auto sampler, swapping out batteries, swapping out ice. You still sometimes have to worry about safe access and the depth to the wastewater. It can be quite deep in a lift station as well. Chances are good, if you're sampling at a lift station, that you're sampling in what's called a wet well. It's just a big well that fills up with wastewater, and then the pumps pump out of that well. Wet wells can be deep. And just like in manholes, it can be challenging to get the intake tubing in just the right place in the flow and keep it there. So let's talk about measuring wastewater flow in the collection system. Flow is one of the required pieces of metadata for submission to Decipher for wastewater surveillance samples, but it can be really challenging to obtain flow information from the sewer. So here are some options for doing that. The best way to get flow data would be to locate your wastewater surveillance sample collection point at a lift station or other location where the utility is already metering flow. As I mentioned before, your utility partner might have sewer systems owned not by them, but by other towns, cities, agencies that flow into their own collection system, say at an interceptor. And oftentimes the utility will meter the flow coming in from that outside sewer district, so they know how much to charge them for wastewater treatment. And because the utility is already maintaining a flow meter at this location, this would really give you the best flow data. The next best option would be to contract with a flow metering company to do temporary metering at your preferred sampling location and see if the site has a good rating curve. So that is just a curve that relates depth of wastewater flow to the actual flow in the sewer. So if the site does have a good rating curve, then what you can use going forward, once you've established that rating curve, is simply measure the depth to the wastewater. And you would measure this from the top of the manhole, which is called the rim, to the surface of the wastewater flow. And once you do that, you can calculate the flow based on the rating curve that you've had your contractor develop. So these sorts of level measurements, measurements of the depth to the surface of the wastewater, can be done with ultrasonic sensors and other types of sensors. And sometimes you'll see these incorporated in what are called smart manhole covers. To make this approach work, you'd have to have a very accurate measurement from the manhole rim. Again, that's the top of the manhole, to the invert. And the invert is just the bottom of the sewer pipe or the sewer channel. And there's always the chance that it won't be possible to develop a good rating curve for your preferred sampling location. Another option would be to install a flow metering insert. Auto sampler suppliers all provide options for flow metering inserts that integrate with their samplers. You could install this flow metering insert temporarily to try to get a relationship between flow in your manhole and, say, wet weather versus dry weather, or you could insert it over the long term for flow measurement during the program period. Another option would be to use a calibrated hydrologic and hydraulic, or H&H model, to estimate flow at your sampling location. So if there is such a calibrated H&H model, the keeper of the model can run the model with the precipitation conditions for the sampling period and then could give you an estimated flow. Now, not all collection systems have calibrated H&H models associated with them, but these models are generally viewed as invaluable by sewer infrastructure owners. All right, if none of these options pan out, then there is a way to approximate, emphasis on approximate, the flow at your sample collection point. And you could do this by looking for some downstream point where you have flow metering in place already, and therefore there are flow data available. And then if you have good data on how many people are in that sewer shed captured at that flow metering location, then you can calculate per capita flows within that larger sewer shed, ideally for both dry weather and wet weather conditions, and use that same per capita flow number combined with the number of people in the upstream smaller sewer shed that is captured by your sampling location to estimate flows at your sampling location during both dry and wet weather conditions. But needless to say, this method is subject to the most error and is not preferred. If you can do one of the other methods, that's the best way to go. So those are basically the options for measuring flow in the sewer. And here are some ways that the collection systems are usually mapped. So the first way is the use of geographic information systems and the development of a shapefile with the collection system boundary. A shapefile is just a digital storage format for geographic information, such as the vector coordinates of sewer shed geometry. One thing to keep in mind is that a shapefile does not inherently tell you which way the sewers flow. But the nice thing about a sewer shed shapefile is that it can be used to intersect with other geographical information such as demographic or economic data or clinical data. But you're going to have to contend with the issue that a sewer shed shapefile will not follow census tract, zip code, county, or even city boundaries. A second way that collection systems are mapped is through as-built, also known as record drawings. This is the set of drawings that's generated at the end of a construction or rehabilitation project for a sewer system. And these drawings show the location, depths, slopes, diameters, and materials of the sewers, as well as the location of manholes, lift stations, and other key features in the collection system. I'm going to show you an example of an as-built in one moment so you can get a sense of what's included on those. But I just wanted to point out that another important source of sewer shed mapping, so to speak, includes institutional knowledge. So the as-builts are only as up to date as the end of the construction period on a given project. And things change over time when minor repairs need to be done or major repairs. So someone in your utility partner organization should have a good idea of how things in the field might be different than what's shown on paper. And so it's always helpful to check with folks in the utility who spend a lot of time in the collection system. Finally, I just wanted to mention there is power in Google Street View. I know it sounds crazy, but you can see manholes in Street View. And so you can probably find information about how accessible a sampling location is, if you're talking about a manhole sampling location, just by using Street View. All right, so here's an example of an as-built from a small town with the plan view on the left, looking down, from a bird's perspective, and the profile or section view on the right. So the profile is just as if you've sliced through the earth and now you're looking head on at that slice. So there's a lot of information on as-builts. But let me point out some of the information so you can get a sense of what you can find on these sorts of drawings. So what you can see in the plan view is the location of the 6-inch Schedule 40 PVC building sewer that flows out of the building number 93. And as you're looking at the plan, north to Main Street, basically, where it ties into an 8-inch sewer main. If you look on the right-hand side, the profile that you're seeing is of that new 6-inch Schedule 40 PVC building sewer. And then you can see in the profile that this 6-inch sewer flows down to meet that 8-inch sewer main. So it flows through 1 manhole, 2 manholes, and 3 manholes. And you can see that for each run of sewer, they're giving you the elevations when it starts and when it ends at the manhole. They're giving you the slope. So you can see here the slope is 0.012. And the other way to think about that slope value is that for every 100 feet the gravity sewer travels horizontally, it's dropping 1.2 feet. That's what that slope value means. Other information on the as-built includes things like the elevation of the manhole covers, in addition to the elevations of those sewer inverts. Again, that's the bottom of the sewer. The elevation, in this case, of the finished floor in this 2-story wood frame building, or the top of the foundation. You can also see the location of catch basins, gas infrastructure, gas piping, water service infrastructure. So there's a lot of information on here. Again, once this gets put down on paper, things can change, and that's where that institutional knowledge becomes very important. So just to recap on the terminology we've covered, the collection system is the system that conveys wastewater from its point of use to a treatment facility. The collection system can also be known as the service area, and its boundary can be called the sewer shed. The collection system includes piping, storage, pumps, and outfalls. A combined sewer, as we talked about in part 1, is the sewer system in which storm drain flows are routed to the same pipe network as the one that conveys sewage, industrial discharges, and I&I. A separate sewer is a sewer system in which storm drain flows are routed to a different pipe network than the one that conveys sewage, industrial discharges, and I&I. A gravity sewer is a sewer in which wastewater flows by gravity. Gravity sewers are commonly called from smallest to largest diameter, laterals, local main sewers, trunk sewers, and interceptors. A lift station is a small structure that houses pumps designed to lift wastewater to a higher elevation. Lift stations can also be called pump stations or pumping stations. A force main is a sewer in which wastewater is flowing under positive pressure due to the action of the pumps in the lift station. A flow meter is an instrument used to detect the amount of wastewater moving through a pipe. And there are many types of flow meters, and all require ongoing maintenance and calibration. A level sensor is a sensor, often ultrasonic, that can be used to detect the depth to wastewater from a given location, such as the top of a manhole. It can be part of a smart manhole cover. An H&H model is a hydrologic and hydraulic model, which is a numerical model that can be used to predict flows at a specific location in a sewer based on precipitation amounts and system characteristics. By the way, H&H models can also be used to predict flows in rivers and streams. A shapefile is a digital storage format for geographic information such as vector coordinates of sewer shed geometry. It's used in GIS analysis, and it's just important to remember it doesn't store information on which way the wastewater flows or topographic information. An as-built is a drawing of a sewer as it was actually constructed versus design drawings, which are drawings of sewers the way they are intended to be constructed. As-built are also known as record drawings, and they are often imperfect representations of reality. So here are some questions you can ask your utility partners to get a better understanding of their collection systems. What type of collection system do you operate? Combined, separate, or mixed? Do any sewer districts other than your own sewer district discharge to your treatment plant? How large is your service area? How many miles of sewer and how many lift stations do you or your member sewer districts operate? Are there any storage facilities such as retention basins or deep tunnels in your system? And the reason this is important to ask is because these sorts of storage facilities can trap solids, wastewater particles. And we're going to talk a lot more about solids and particles and wastewater characteristics, like characterizing wastewater in part 5 of this series. But if you're trapping those solids in these storage facilities, in the collection system that you are monitoring, then you're going to want to know that because the nucleic acid targets for pathogens being monitored through wastewater surveillance tend to associate with those solids. So trapping the solids in the retention basins or the deep tunnels means that you're also trapping your nucleic acid targets, which means that it just might complicate sort of the message you're getting from your wastewater signal for wastewater surveillance. How do you map your collection system? Using as-built or record drawings, GIS? How up to date is your mapping information? Where do you currently meter flow, if at all, in your system? And do you by chance have an H&H model of your collection system? And if so, has it been calibrated recently? And do you have a lot of confidence in the results that it gives? So here's a shameless plug for some collection systems resources from WEF. The first QR code on the left will take you to Wastewater Collection Systems Management, which is WEF's Manual of Practice, or MOP 7, and the 7th edition of MOP 7, published in 2021. The second QR code will take you to the Wastewater Collection Systems Community, which is one of WEF's communities. And the third QR code will take you to information on the Wastewater Collection Systems Conference. This was part 2 of Wastewater 101. How is wastewater collected? Other parts in this series include part 1, what is wastewater? Part 3, how is wastewater treated? Part 4, where does treated water go? And related to that, what are permits all about? Part 5, how is water quality monitored? And part 6, who works in the wastewater sector? Thank you so much for your attention. If you have any questions about this content or would like to talk to us about personalized trainings for your organization, please visit nwbe.org or email us at nwbe@wef.org.